Yeah. So when x is less than 0, so if I draw the line here again, so the interval is from x is greater than 0 and less than 1, right? So here is 0 and 1. So we have to consider firstly this part when x is less than 0. Then we have to we have to include the 0, okay? And then take this part, and then again we have to include 1 and then calculate this part. Okay, so this is how we calculate. So the first thing here, when x is less than 0, so you see there is no value here, right? There is no value. When x is less than 0, there is no value. So it is 0. So from minus infinity, this direction here, this is plus infinity and this is minus infinity, right? From the real line. So when x is from minus infinity to x, that means from minus infinity to 0. So here there is no value, right? So we write down here 0. So derivative of 0, derivative of 0 will be maybe 1, right? Maybe derivative of 0. What is the derivative of 0? Maybe it will be x. It should be x, maybe. Just a second. So derivative of 0 is 0. That's why the value here, the final answer here is 0, okay? And now when x is from 0 to 1. So now we include 0, right? And also we include this part. X is from 0 to 1, but 1 is not included. So up to 1, okay? That means from here, okay? We don't touch 1, but it's from 0 greater than or equal to 0 and then less than 1. So we don't touch 1, but we just calculate this part, okay? And from infinity, from here to infinity direction. So we write down here the same formula, integration of minus infinity to x. So here, firstly, we see here is 0, right? In the interval here is 0. So firstly, from minus infinity to 0. And as we calculated here above, so minus infinity to 0, that is 0, right? So this part, it will become 0. And then the next part, from 0, now we take this here, the upper limit here, okay, in the lower limit. So from integration from 0 and to x, and from 0 to x, the function is here given, right? The function is given here. The function is ax plus half. See, the function is ax plus 1 by 2. So we have to take this function now, and we have to integrate this one. So you see here, we instead of x, we just let it as t. But don't worry, because here the upper limit is x, right? Here the upper limit is x. So when we substitute the upper limit here, when we calculate the boundary, so then you will then this t will replaced as x, okay? So derivative of t is t square by 2. Derivative of t is t square by 2. And then we replace the t, right? So it will be x square by 2. And then derivative of 1 by 2, it will be x by 2, right? So derivative of 1 by 2 will be t by 2, but when we put back the boundary, so it will be x by 2, okay? So this is the answer, x square minus x by 2. And when now we have to consider this part. When x is greater than or equal to 1, that means on the right side, okay, here. When x is greater than or equal to 1. So now we include the 1, okay? Now we include 1. So x is from 1 to infinity, okay? So this part. So now we include this part and we include 1. So we again see that there is no value here, right? There is no value here. So the answer will be 0 here. So you see here, sorry, the answer will be 0, but as you know that we don't only calculate x is greater than 1. So as you know that we calculate the whole part from the previous so here x is greater than or equal to 1. That means the whole thing from 1 to the right side and also from the left side. Okay, the whole thing here, as I explained above, right? You see here when I calculated here, so I told that for x is greater than our value, so we just take all these numbers, we go from this number to the left direction, right? And we add all them together. So that is called the total probability. So here in this example, when okay, so when x is greater than 1, so let's say here is 0 and here is 1. So we take when x is greater than 1, that means this direction. So we take this direction and also we add the previous probabilities. So that is called the total probability. Okay. So it will be equal to 1. Maybe I have written a small formula here in my notes. If you look back here, you see here, when x is greater than b, then the result will be equal to 1. See? So this is called the total probability formula. So the same way here, okay, the same way here, the answer will be 1. Okay, if you calculate manually, so you see this part here will be 0, and this part we got this the answer here. The answer is x squared by 2 minus x by 2, x squared by 2 plus x by 2, x squared by 2 plus x by 2, right? So if you calculate if you just okay, so you see here, x is greater than or equal to 1, right? So here our boundary is from firstly from minus infinity to 0 and then from 0 to 1. And so we put the upper limit here, right? We calculate the boundary. So t plus 1 by, we already got the answer in here. It will be x squared by 2 right here. X squared by, so here is the answer, x squared by 2 plus x by 2. Okay, here x squared by 2 plus x by 2. So if I write down here, x squared by 2 plus x by 2, and then the boundary is here from 0 to 1. So we put the upper boundary here. So 1 squared by 2, and then plus we again put the upper boundary here. So 1 by 2. So that is 1 by 2 plus 1 by 2, that is 1, right? And then this part, it will be 0, and this part, it will be also 0. So 0 plus 1 plus 0, the answer will be 1, right? That's why the final answer here is 1, or this is the total probability. So this way, we already got the final, we already got our answer. That is the distribution function. So as you see here, for the first one, when x is less than 0, right here. Number 2. So here, when x is less than 0, the value is 0, right? And then when x is from greater than, when x is greater than 0 and less than greater than or equal to 0 and less than 1, the answer is here. And then at the last part, when x is greater than or equal to 1, the answer is 1. So we just write down here, okay? X is less than 0, the answer is 0. X is from 0 to 1, so answer is here. And x is greater than 0, so the answer is here. So this way we calculate the second one, and the third one here, that is probability of x is less than or equal to 0.5. And again, when the probability of x is equal to 0.5. So x is less than or equal to 0.5. So we already got this answer here, right? From x is from 0 to 1. So 0.5 will be between here, right? So that means we have to calculate here. Now let's take it out and now just put the value x equal to 0.5 square by 2, and then plus 0.5 by 2. Okay. So the answer will be 0.375. Guys, do you understand here?
Yeah.
So
it's
here,
okay. I need more practice. I mean, I need more practice to understand this.
See here, x is less than or equal to 0.5. So it is the same as f of 0.5. So you see here 0 and 0.5 is between here, between 0 and 1. If I draw the line here, so x, if I draw the line here, it will be 0 is here and 1 is here, right? So 0.5 will be here. And so for 0.5, the distribution function here, the value is here, x squared by 2 plus x by 2. So now we just substitute the value here. So the value is 0.5. So we substitute the value in x, okay? So x squared, that means 0.5 squared. Then divided by 2 and plus x by 2. So here x is 0.5. So 0.5 by 2. The final answer is 0.0375. And okay, so guys, do you remember this is a continuous random variable, right? That means we are integrating here. We are just working on a integration part, right? This way. So we are finding some area. But when we have to calculate f of when we have to calculate probability of x equal to 0.5, so this is not an interval. This is not an inequality. This is just a point, right? X is equal to 0.5. So that point may be somewhere around here. See here? That point can be somewhere around here, right? Here. So we know that for any point, just for a point, there if there is a line, so this line doesn't have any area, right? This line doesn't have area. That means no area here. So as this is a continuous random variable, and for any point, there will be no area, okay? No area for this point. So the result will be 0, because if there is no area, so the result is 0, okay? So this is how we calculate the distribution function for continuous random variable, okay? Because we see here it is written others. That means there is more option. So that's why this is continuous random variable. And I think Laushi will not give this kind of question in the examination, because she already told that this is quite hard. So continuous random variable. So we don't need to worry too much about this continuous random variable. If we somehow,
it's good.
Yeah, right. So if we somehow can calculate the discrete random variable, here I have calculated, right? So number 7. So if we somehow know how to calculate this one, so it will be okay. And now let's see number 9. Let the distribution law of x be here, and then find the distribution function of x and find f of 0.7. So this is also a discrete random variable. And now from the definition, we obtain that the distribution function is here. So okay, so I think you guys can find this one, right? When x is less than -1, that means this part here there is no value, so here is 0. And when it is from -1 to when it is from when x is greater than or equal to -1 and less than 0, so we just add 0 and plus 1/3. So the answer is 1/3. And when x is greater than or equal to 0 and less than 1, so we just also include this value. So 1/3 plus 1/6. So it will be 6, and then 2 plus 1. So 3/6 or 1/2, right? So we get here 1/2. And when x is greater than or equal to 1, so I mean the whole thing here, right? So you just add all of them, and the answer will be 1. Directly this one and this one you can just write down without calculating, because the probability is from from 0 to 1, right? So, and then the between part, just add them together, okay? It is just the addition. And now, what is f of 0.7? F of 0.7. So where is 0.7? 0.7 is between 0 and 1, right? Between 0 and 1. So here the answer is half, 1 by 2. So the answer will be 1 by 2, okay? Now it was pretty much easy, right? So now let's go back to number 10. X follows normal distribution 2 and 4. So find the P of X is greater than 1. So for normal distribution, this is the value of mu, and this is the value of sigma squared. So if sigma square equal to 4, you can, you see here sigma square equal to 4. So sigma will be equal to square root of 4, that is 2, right? So we got the value of sigma. So sigma is a standard deviation, okay? Sigma is a standard deviation. So if I draw some graph here, the standard deviation tells us how fat or thin this graph is, okay? So this is the standard deviation. And mu represents the mean value, okay? So mu represents the mean value. That means where in which position, in which number mean means most of the number are around the mean, okay? You have to know that most of the values are around the mean. So if we have some sample here, let's say some sample here, okay? And some sample here and here. So you see, most of the items, it is around the mean. So this is here, it is the mu or mean. And then standard deviation means how fat our graph is. That means how much data we have here, okay? So if mu is smaller, then the graph will be if sigma is smaller, so the graph will be this way. It will be thin, okay? And if sigma is larger, so the graph will be fat, okay? This way, fat. And we can also move the mean value on the right and the left side. So let's say this is a mean here, and if I somehow take it on the right side, so we will have a mean like this way, okay? We are taking the mean on the right side. That means the value of mu changes, okay? So that is just a general idea of what is sigma and what is mu. So mu is like a mean, and sigma is a standard deviation. So the first question here is, this is a normal distribution, right? X follows n. So here mu is 2 and sigma is square. So sigma is 2 and mu is also 2, right? Guys, can you see here? Mu is 2 and sigma square is 4. That means sigma is equal to 2. So the first question here, probability of X is greater than 1. So when X is greater than 1, okay. So if I draw the line here, X is 1 here, X is greater than 1. So we use here the what do you call here? So we use the formula here. When X is greater than 1, it will be 1 minus X is less than 1. X is less than or equal to 1. So X is less than or equal to 1. This is easy to calculate. So the formula is, if I share my notes in the last part, this is 10(1), right? It's W10. Yeah. So see here, the formula here is f of X is equal to phi X minus mu by sigma. So here X is here, okay? X is greater than or equal, X is greater than 1. So that means the value of X, we for this example here, we let the value of X equal to 1. So here X is equal to 1, okay? This one is here. And then minus 2. So 2 is the value of mu. So we know that here the value of mu is 2. And here sigma square equal to 4. So sigma will be equal to root over 4. Or here is 2, right? So 1 minus mu by sigma. Okay. And then the answer will be minus 0.5. And now let's see when. Okay, now let's see number 10. Okay. Yeah. Yeah. So when, and let's see number 2. Probability of absolute value of x minus 1 is greater than 1. So we know that for absolute value of, okay, let me go here, number 10. Okay, here, okay. So for absolute value of x minus 1, that is greater than 1. So we know that for absolute value of x minus 1, that will be greater than on or less than minus 1. You know, guys, we learned this in the previous semester. When modulus x is greater than 1, it means x is greater than 1 or x is less than minus 1, right? So here the same way, modulus x minus 1 is greater than 1. That means x minus 1 is greater than 1 or x minus 1 is less than minus 1. So now if you just calculate the inequalities, so we take minus 1 on the right side, so it becomes plus 1. So x, it will be plus 1, right? So 1 plus 1, that is 2. X is greater than 2. And if I take minus 1 from to the right side, then it will also become plus 1, right? So minus 1 plus 1. So minus 1 plus 1 get cancelled. So we get x is less than 0. Okay, guys. So now we have to calculate when x is greater than 2 and when x is less than 0. So see here, x is greater than 2, right? And x is less than 0 plus. So we have to also add them. Now we know that the formula 1 minus when x is greater than 2 and when x minus when x is greater than 2, right? So you see here, I have calculated when x is greater than 2, so x will be 2, and then we know the value of mu. Already we know the value of mu, and here sigma equal to also 2. So 2 minus 2 by 2, that is 0. That's why I have written here phi of 0, okay? And then this part here, phi of minus 1, because if you calculate here, x is less than 0, that means here x is 0. So 0 minus 2, that means the formula is here, okay, x minus mu by sigma. So x is 0, so 0 minus 2 by 2. So the value is minus 1. That's why I have written here phi of minus 1. And then you have to also know that phi of minus 1. Phi of minus 1. We can also write down this way. On minus phi of 1. On minus phi of 1, okay? So 1 minus phi of 1, the value of phi, if I calculate here, so Laushi will give us the phi value, okay? Phi of 1 and phi of 0. So the answer will be 0.6587. You can use your calculator. So this way we, so why phi of 0 is equal to 5? So let's say this is a normal distribution, and the half, 0.5 means half. So the half part will be on the left side from the mean, and half part will be on the right side from the mean, right? So that's why phi of 0, 0 means the origin. So here in the origin, phi of 0, so it will become, here it will be minus 1, here it will be plus 1. So sorry, here it will be minus 0.5 and here it will be plus half. So that's why it is 0.5. I mean, if you know, like 95% of the event, they will occur plus or minus 2 times sigma, okay, in this region. So if sigma equal to, let's say sigma equal to 0.5, so most of the event will occur between, let's say 0.5 is here and 0.5 is here, right? Here is 0.00, so 0.5 is here and let's say 0.5 is here. So most of the event, they will be they will be between this region. Okay, so this is what we this is how we just understand this normal distribution graph. Okay, so now let's see number 11. The distribution law of random variable x is here. So -2 and 2a. So we have to find a, right? And you see, we have to find a, right? Number 1. So it's very simple, like 4 2a plus. So it's very simple. We know that our total probability is equal to 1. So we have to just add them together and we have to write down is equal to 1. And then we calculate for the value of a. So if I add them together and write down is equal to 1, so I can use some algebraic form. I can just do some simple algebra and I can get the value of a. So a is equal 0.1. And number 2, we have the distribution law of y equal -2x. So you see y equal to -2x. So here y is equal to -2x. So I have to multiply -2. I have to multiply -2 here. Also, I have to multiply -2 here. Okay, I have to multiply -2 with all the x value. So I will get 420 -2 -4 and then -6. And so again here we have z. Z is equal to x squared -1. So the same way I have to square the x value. So -2 squared, that is 4, and then -1. So 4 minus 1 is 3. Okay, so here is 3, and this way I calculate x squared -1. And then pk is already given in the question, right? 0.2a. So pk is not given, but we just substitute the value of a here. Okay, you see here 2a. So 2 times, we already got the value of a. So value of a is 0.1. So 2 times 0.1. So it will be 0.2, right? So this way you just calculate pk, substitute the value of a, and thus you get the new distribution, right? And yeah, the distribution law for y equal to -2x. And you also get the distribution law of z equal to x squared -1. Just to write them separately. So you just take this here and take this here. And again, you just take this here. Oh, sorry, z. -6 -4. Okay, so just rearrange them. Okay, you see the value here, -2 -1 0 1 2 3. So you just rearrange them, or not x, and we don't take x. Let's say we have here so for y we have 4 2 0 -2 -4 -6. So we know that the smallest value here is -6, and then -4 -2. Okay, you just rearrange them and then write down here. And then for z, take the value from z and write down here, and take the probability and write down here. Okay, so this is very simple. Just rearrange them and write them here. Number 12, x follows the normal distribution 1 4. So here mu is equal to 1 and sigma is equal to 4. So sigma will be equal to √4 is equal to 2, right? And find the probability of x is greater than 1.2 and less than 3. So 1.2 and less than 3. So you see here the highest value here is 3. So we write down this way 3, and then -1. 1 is mu and 2 is sigma. So x minus mu by sigma, the same formula before. And here it is 1.2. So we write down here 1.2. So minus, here is minus mu of phi of x minus mu by sigma. Okay, so the value is 0.3015. And when x is less than or equal to 0, that means here. So here the value of x will be 0. So 0 minus 2, that means 0 is x, right? X minus mu by sigma. So 0 minus 2 by 2. It will be 0.3085. And the last part here, when probability of modulus x is less than or equal to 1, so we know that it will be modulus x is less than or equal to 1. It means x is less than 1 and or x is greater than minus 1 maybe. Yeah, so this way. And so we see here 1 minus 1, right? So you see here x is 1 and here x is minus 1. So that's why we write down this way. X is less than or equal to 1. So x is less than 1, x is greater than minus 1, right? So here is x minus mu by sigma. Again, minus x minus mu by sigma. This is x and this is also x, okay? That I have written here, this one and also this one. Okay, guys, and this is for mu. This is for sigma that we already know. This is mu. This is sigma. This is x. And now the final answer will be here 0.3413. And this is the homework 3. Let the distribution law of x be, this is the distribution law. We have to find e of x. E means expectation, okay? Expectation. So e of x, e of minus 2x plus 1 and e of x squared. So expectation, so total expectation, we just multiply them. Minus 1 times 1 by 6, 0 times 1 by 4, 1 by 2 times 1 by 6, 1 by 12 times 1 by 1 times 1 by 12, and 2 times 1 by 3. And then we have to add them, okay? So we get the e of x. So if you look here in my homework 3, you will see that, okay, just, yeah. So the formula is expectation e of x equal to e of x equal to summation of x k p k, right? So we just multiply them and then we add them. This summation sign means addition. So we add them and then we multiply them. So the answer will be 2 by 3. And for the second question here, this is e of minus 2x plus 1. So e of minus 2x plus 1. So e of minus 2x will be, we just take minus 2 out. So here is minus 2 into e of x, and then here is plus 1. So here is plus 1, okay? So e of x, we already know the value of e of x here, right? E of x equal 2 by 3. So we write down here 2 by 3. So minus 2 times 2 by 3 plus 1. So the answer is minus 1 by 3. And then e of x squared. So look here, this is x squared. That means firstly we have to go back to x and then we have to square them. So let's say here the value of x is here on the first row. So we have to firstly square them. So minus 1 square will be 1, 0 square will be 0, 1 by 2 square will be 1 by 4, 1 square will be 1, and 2 square will be 4. So this is x square, okay? And then what we do, we just multiply them, okay? 1 by 6, 1 times, 0 times. Yeah, we just multiply them. So 1 multiplied 1 by 6, then 0 times 1 by 4, 1 by 4 times 1 by 6, 1 times 1 by 12, and 4 times 1 by 3. And then we have to add them, and we will get the final answer 13 by 8. Number 2, we have let the probability density of random variable f of x equal to 1 plus x when x is greater than or minus 1 and x is less than 0. 1 minus x when x is greater than or equal to 0 and less than 1, and 0 others. So Laushi mentioned that she will not give this kind of problem in the examination. So this is, you see, the continuous random variable, right? Continuous. So we have to find e of x and e of e to the power x. Okay. So the same way, like firstly, e of x, we have to see it's from minus 1 to 0, right? You see here minus 1 to 0, the first interval here. And then the formula is, you look back in my homework. The formula is here. E of x equal minus infinity to minus infinity to infinity x f of x dx. Okay, x f of x dx. So we have written extra x here, and the f of x is this function 1 plus x. Okay, f of x is this function. So firstly, we just integrate them. So you see here from minus infinity to plus infinity, we have here two. We have here two interval, right? First one is from -1 to 0, and the second one is from 0 to 1. So here you see -1 to 0 and 0 to 1. And then for -1 to 0, the function is 1 plus x, and from 0 to 1, the function is 1 minus x. So 1 plus x and 1 minus x. And if you just multiply them, x times 1 is x, and x times x is x squared. So x plus x squared. And then the integration will be x squared by 2 plus x cubed by 3, right? X cubed by 3. So then we just substitute we just calculate the limit here, the boundary here. So boundary is -1 to 0. So if you do the calculation, I mean, this is just a simple integral. So you will get the final answer here. This is 0, okay? And expectation of e to the power x. So e to the power x will be the same way, like here it will be e to the power x times the function. E to the power x times the function, okay? And the boundary is same as before, the interval that is given. So in this integral, this is also, you can calculate using any software, or you can calculate by your own. But I think Lausi will not give us this kind of example. So just calculate the integral and substitute the boundary here, and you will get the final answer here is 1 by e plus e minus 2. So I have also experienced, here we use integration by parts rule, okay? And for instance, I have given some notes, like how we calculate the integration by parts. So you see here the use selecting formula, I love paid. So firstly, we think of, when you select u, we think first the inverse function, then log for log function, p for power function, e for exponential function, and t for trigonometric function. So this is the things that we learned the previous semester. So I will not explain them. And this is the answer for e to expectation of e to the power x. 1 by e plus e minus 2 here. And now let's see the third question here. Maybe we have less than 1 minute, so we will try to join again, okay? If you guys like so.